Want to get a bit closer to that authentic retro computer feel? Let's have a look at bare metal emulators on the Raspberry Pi. Hi and welcome to Bytes and Bits. If you're into retro gaming, you've no doubt already set up emulators for your favourite computers on either your PC or maybe in RetroPie, and you've been able to play all your games and have all that fun reliving all of those memories. But sometimes it's quite nice to get a little bit closer to the actual original feel of using that computer. Now obviously you can go out and you can still buy a lot of the sort of 1980s 8-bit computers and get those set up at home and so on, but that does involve a lot of hassle, and obviously there's a lot of maintenance. These machines are now hitting 40 years old and the electronics are starting to fade a bit, so you will need to maintain those, and obviously then interfacing them into modern monitors and TVs does involve a whole lot of effort. And again, that is a hobby in itself. So in this tutorial, I'm going to look at a halfway house solution where we can get a lot closer to the original feel. And indeed, we can actually build some replica machines using this technique. But it does then allow us to use modern hardware so that we can easily interface then with our modern game pads and our modern monitors. So we're going to be looking at what's known as bare metal emulation. So let's first of all have a look and see what that actually is. So for this video, I'm going to be using a Raspberry Pi as my base processor. So if we think about how a Raspberry Pi is normally organised, we have the hardware itself. And when you first turn that on, there is a BIOS layer that needs to be loaded, and that's usually sort of in ROM or at least in sort of firmware, and that loads in pretty quickly. On top of that then, once it's up and running and the system has access to all of the hardware devices, it can then load in the operating system, which of course in our Raspberry Pi is usually some version of Linux. And then once that loads in, we then get into our applications and we can load in things like our actual emulators and start playing our games. But if we think about this sort of load sequence, so when we first turn on, the BIOS is almost instantly loaded in. That is coming out of some sort of memory device. After that then, of course, our Linux boots up, and that does take maybe sort of 10-15 seconds to go through, load that in off the SD card and boot up. And then we drop into either our Linux desktop or we might have it set up to automatically go straight into our emulator. But there'll be some sort of messing around, then of course getting our emulator up and running out to our actual computer screen, and from there we can start playing our games or doing whatever we want to do with our system. So for our bare metal emulation, really what we're doing is we're trying to put our emulator code as far down the sequence as possible. So obviously we need to have our BIOS layer because that gives our code access to the hardware devices. But then we don't need to have any operating system layer. We can simply go straight into the code that runs our emulator. And this really means then that once we turn our computer on, we're really bypassing all of that sort of modern operating system level and going straight to the code that emulates our retro computer. And that really just means then that we almost get down to the same sort of instant on that we would have if we had the original hardware. And as these bare metal emulators tend to not have a sort of graphic gaming front end, we will also drop into the standard prompt that you would get on the original machine. So to put one of these systems together, you're going to need some hardware. So we've got our Raspberry Pi as our base processor, but after that you can be really as original as you want. The bare metal emulators tend to allow you to connect the original hardware up to the GPIO pins on the Raspberry Pi. So you could, if you want, just buy an old non-working computer and then just strip out the insides of that and put in your Raspberry Pi instead. And indeed, there are some companies who allow you to do this very simply, where they will supply you with a ready-made original computer, all cleaned up and refurbished, ready for you to fit with your Raspberry Pi. Now for me, I'm going to use a slightly different approach. I'm going to use modern keyboards and so on. And really what I'm doing here is I'm going to use a little 10-inch screen, HDMI screen, and I can bolt a Raspberry Pi on the back of that, so I have a nice little unit there. And then I'm just going to use a wireless keyboard to connect to that. I'm really going this route here so that I can really create a number of bare metal emulators, and I can just simply switch them in and out by changing the SD card in the Raspberry Pi. And this then, using the standard keyboard, allows me to emulate a range of these machines using this bare metal technique. And again, the downside here of course is that I won't be using an original keyboard, so I will have to be careful with the keyboard mapping to be able to use the interfaces on the actual real machines. So that's the basic idea of what we're doing. So let's get set up with a Commodore 64. The emulator we're going to use for this is called BCM64. So if you go to the website for that, which is here, and again I'll put the link to this in the description down below, and don't forget to also have a look at the main project page on my bytesandbits.co.uk website, where again there's more information and you can follow through the instructions on there. Now, one of the really nice things about this emulator is it also includes some bare metal versions for the other 8-bit Commodore computers. So once we install this, we will also have installed the bare metal emulators for the Commodore PET, the VIC-20, the Commodore 128 and the Plus4. Now, the actual emulator itself is based on the Vice emulator code, which is one of the main Commodore 64 emulators for sort of desktop PCs. But of course, it's been rewritten and optimized then for use on the Raspberry Pi, but again running on the base hardware of the Raspberry Pi rather than inside an operating system. So if we go to this website, if we scroll down a bit, you'll see it here takes you through sort of various features. And again, one of the main features of this emulator is that it is designed if you are trying to build, in effect, a replica of the machine, as we talked earlier on, where we can actually hook up real keyboards, you can put it inside a case, and in effect you can build a modernized replica of the computer you want to run using some real hardware. But again, we're not going to look at that in this particular tutorial. So what we want to do is we want to get hold of the actual software to install that onto our SD card. So there are links off here. The actual source code is available if you want to have a look through that and see how it's all put together. There are then two ways of installing the software. One is where we will actually build up the SD card ourselves and install the files on there ourselves. But the much easier way then, and what I'm going to take you through, is using just the built-in SD card image, which we can simply burn using any of our SD card burning software. So down here, if we download that file, that image file, it comes down as a zip file. So if I come out of that, and really all we need to do now is to use something like the Raspberry Pi Imager to burn that onto an SD card. So we've now got our SD card burnt. If we have a look at what's actually inside it, so I've just plugged the SD card back into my computer, we can see that we have our drive now, and there's a number of folders in here. So if we have a look inside the C64 folder, you can see that there's a number of files in here, and these are a number of sort of files that help make the Raspberry Pi work. But there's also this note then to put ROMs in here. So at the moment, the actual emulator hasn't got the ROM files it needs to actually work. And you can see that sort of listed out here. So it's saying here that you must obtain at least a minimum number of these files. And what it does underneath that then, it actually takes you through and tells you what files you need to put into the system. So to get hold of these files then, it does give you an example here of one area, but actually the easiest way to get them all in one go is to actually download a copy of Vice. So Vice of course uses these ROM files as well, So if you head across to this web address here, and again I'll put a link to that in the description, if you scroll down you'll find the download files then for Vice. So you need to just go off and download one of these. Again, it doesn't really matter because we're not going to be using these as such, but if you do want to have a play with Vice, obviously download the one for your computer. So if I was to download that, it takes me off to the SourceForge file, and again I will eventually get my download. If we now go and have a look inside that downloaded zip file for Vice, well, once we get down inside it, you'll see that again we come to a set of folders, and again these folders here are sort of matching up with the ones in our BMC folder. So we have a Commodore 64 folder here, and inside that you'll see we have a number of ROM files. Well, that's what these are, these files in here. These are the ones with .bin at the end of them. So we need to get some of these files across into our USB drive. Now we need to make sure that we get the right files, because you can see here things like the chargen and so on. There are a couple of variations on those. So if we have a look on our system over here, so we'll need a kernel file, a character generator file, a basic file. The D1541 is a disk operating file, so that's for the floppy disk drive, and that's really what we need then to get up and running. So if we have a look at this example, this actually lets us see which ones are which. So if we go across to that, if we have a scroll down here, we can see that we have two versions of BASIC here. So we have this BASIC 901.226.01, and that then of course is the actual Commodore 64 BASIC. The one beneath that then is a Commodore 65, which is a computer that never really made it out into the market. So if we have a look in our folder here, we should find that we have that basic file there, sitting there. So I'm going to need to use that. So I'm going to copy across my basic file. So I'm going to copy that. Then I'm going to jump across onto my BMC file. I'm going to paste my file in there. Okay, so we now have that sitting in there. If we do have a look back at what it said to do with it, it has to be called just basic, no file extension. So if I now come in here, I'm going to come in to this, and I'm going to edit that file name. I'm going to take it all the way down just to basic. And yes, I do want to change that. And we now have our basic ROM installed. We now need to get our, go back into our example here. So we need a kernel file. And you can see that there are a whole range of kernel files sitting in here. So the little descriptions beside it here do tell you which one's which. So for me, it looks like this, if I'm going to sort of use a sort of an original Commodore 64 style computer, then that revision 2 might be fine, or I might want to use my revision 3 to get the latest Commodore 64 version. So let's go with this latest one here. So kernel 901.227.03. So if we go back into our Vice area, so back into Vice, so it was the kernel, if we come down here, so it's the 03 version that we want. So again, we're going to copy that. And then we're going to go across back to our Commodore 64 on our BMC version, paste that in there. And again, we need to get it right down to just the word kernel as its file name. And that is the kernel installed. So again, we need to go through this process then for our other files. The only one which is going to be slightly different is this disk driver. So if we come back across into our example, we'll see that the drives are up here. So we can of course download it from here. So you can see there's a 1541 drive in there. And there's a whole range of ROMs that we can use. But if we go into our Vice area, I'm going to go up a folder. I'm going to go into my drives, and we'll see that there actually is the DOS 1541 version 2 ROM sitting there. So let's use that one. Go back across to my BMC, paste that in. Now again, we do need to make sure that that file name matches exactly. So let me go back out here. And the file name we need to use is D1541II. So let's go back into my folder. So again, we need to rename this. So we need to get rid of that bit at the end, and we also need to get rid of the OS. Okay, so I have my BASIC, my kernel, my disk drive. I simply need now my character generator file, and that should be us ready to go. So let's go back across into our example here to work out what character generator we want. So we come down here, we want our character generator file. So there we have our characters, and there only is one file in here. So if we come back across to our, oh, yes, we'll do that. Come back across to our drives. We're going to come up one folder into Commodore 64 again. Our character generator here. So it's saying here the character generator ROM is the 901.225.01. So 901.225.01, it's that one there. Let's copy that. Stick that into our USB drive. And then just rename that down to just car gen. And that should be fine. Okay, so let's have a look back in our BMC list here, and then on our actual USB drive itself. So we've got our boot stat, we've got our RPI SYM, we've got our kernel, we've got our character generator, we've got our BASIC, and we've got our disk drive ROM. So we should now have everything we need to get that Commodore 64 up and running. Now you'll see as well there are some other machines in here which we can emulate. And again, the process is going to be exactly the same. So if we want to use the VIC-20, we will have to go in here to find out what files we need for the VIC-20. And again, you can see them listed down here. Again, if we go out to the example page, we can see here the VIC-20 files. We can either download them individually from here, or we can use our Vice installation to pick those files out and just copy them across. So again, we should have enough information now to get all of these machines, all of their ROMs installed so that we can use them. But I'll leave you to go through that. I'm just going to concentrate now on the Commodore 64. So the last thing we need to get onto our USB drive then are some actual programs to run. So if we look back on the root of our USB drive, you'll see that we have a couple of folders here for our cartridges, our disks, and our tapes. So it's really just a matter of getting hold of some of the game files and then putting them into the relevant folder. So I've got a few of D64. So these are Commodore 64 disks, which I've downloaded. Again, you'll have to find these yourself. They're not that hard to find. If you do have a look on my main project page, I'm able to help you a bit more out there. But once you've got hold of those, all we need to do is to put them into the correct folder. So if I copy those, go across onto my USB drive, so in my disks folder, there's a Commodore 64 disks area, and if I paste everything in there, then when I run BCM64 to emulate my Commodore 64 and ask it for a disk drive, it will automatically look in this area for me. So we've got all of our disks in place, all of our ROMs in place. Let's see if everything boots up and works. So I'm just putting the SD card into the Raspberry Pi, which is actually mounted on the back of the screen. And if I then turn that on, we do have a slight delay with this screen as it sort of initializes itself and powers on. But once we actually get through that, we should drop into a Commodore 64. So let's have a look at that just on the screen capture. So you can just see the actual delay in getting the Commodore 64 up and running. So if I start from scratch and turn the power button on now, we should get a delay for about sort of 8 or so seconds. And then we drop straight into our Commodore 64. And we are now sat as if we were at a real Commodore 64. So it drops straight into BASIC. So we can try typing in a little BASIC program. So our usual sort of little for next loop. So if we then do our print statement, and then our last line is our next A. And if we run that, that then shows that all of our ROMs and our basic ROM and everything and our character generators are all working correctly. Now naturally you're going to want to play some games on this, and for that we need to get a few things set up. Now first off, The BCM64 does not allow you to hot plug USB devices into the system. So anything you want to have available to you, you need to plug that in before you power on the Raspberry Pi. So I have a game controller plugged in, and I had that plugged in before I turned on. So we need to get that set up. So with this system, it is based on Fuse, so we do need to use sort of the Fuse key bindings and so on. Obviously, I was getting a bit carried away here, and I did mean to say Vice. It is all based on the Vice emulator. And if you're not familiar with what those are, I'll put a PDF link on the main project page where you can download and print out a keyboard overlay. But the main ones you want to use here are the F12 button takes us into the emulator menu. And now we can use our cursor keys to navigate around this. So first off, we need to come down and we need to set up our joysticks. So we go to the Joy Ports menu. First of all, we need to find out where our joystick is connected. So if we go to our USB gamepad 1, let's just check if it's in there. So if we come in, we'll see there aren't very many options here, so it doesn't look like this is going to be the one. But if I go to monitor the USB 1 data and click on that, as I press buttons on my controller, you can see that nothing is changing. So that's not connected up to our actual controller. So if I press escape to come back out here, if I go into USB gamepad 2, you can see we've got a lot more options now. And at the top there, it does say that it has detected 0 hats and 5 axes. So if we come down to monitor our raw data, we need to find out which particular buttons and axes our system is using. So we can check which buttons we have. So I'm going to press what I want to be the fire button on my controller. And you can see that that is coming up as button number 8. The other buttons, of course, will give up different numbers, but the one I want to use as fire is button number 8. If I then press, I've got a hat key on my controller, so if I press left and right, you can see there that axis 3 is the one that is changing for my left and right, and up and down is axis 4. So button 8, axis 3 is our X connection, and 4 is our Y connection. So if I come back out of that screen there, we just need to make sure we enter those in. So we need to use an analog plus pot X, Y and buttons. That seems to give us the best one. So our X axis then, if I use my left and right buttons, so that's axis 3, my Y axis was axis 4, and my fire button was button number 8. So I want button 8 to operate as my fire button. And that now has set up this joy port. So if I come out of here, we now need to, so our gamepad 2 is what we're using and it's all set up. So I'm going to want to connect that into port number 1. So if I go to gamepad number 2 for that. So we should now have our joystick all connected up. So once we've set up the way we want it, we do need to come down the bottom here and click on Save Settings. So that will actually save any of the setting changes we have made to our system, so that when we reboot, our joysticks and whatever else we've set up will all be restored. So let's go and get a game up and running. So I can run my games through the Auto Start a Program or Disk option. So if I go into that, you can see that it comes out to my USB drive, and we put our games into the disks folder and into Commodore 64. And if I come down, I could start up the game Uridium, and I click on that. And what it's doing now is now attach that file as a floppy disk drive to our Commodore 64. It's typed in our command to load from disk 8, and you can see it is now searching for that file. Now, at the moment, we have it set up in its basic settings, so it will do everything at proper emulated speed, including the very, very, very slow disk drives. Again, not quite as slow as tape drives, obviously. But we do need to go through this process. Well, there is an option in the settings to put it into turbo mode, and basically what that does is when it's sitting there waiting for disk drives and so on to load and the actual loading of the data itself, it just in effect sort of speeds through those, because obviously we don't have to wait for any mechanical processes going on. But as you can see, eventually we do get to the actual data coming off the disk. That's loading in then obviously at the standard speed. So eventually that will actually get the program loaded in here. I do promise it will eventually get there. So there we go. So this, of course, is a hacked version of the disk file to get us past any sort of piracy sort of protection. So if we come into here, this will then take us through some information screens. And this is where we do need to be aware of what the keyboard bindings are. So obviously space is the space bar, but the run stop key was a special button on the Commodore 64, which of course doesn't appear on a standard keyboard. So the mapping for that is actually to the escape key on our standard keyboard. So I press escape key, that should head us towards the actual game itself. And we go through there and just get through these screens. And then we should drop into the actual game Uridium. And there we go. So we're up and playing now with Uridium, and hopefully our keypad will now work. So if I press the fire button, that should start the game and we should be into it. And there we go. So I do warn you, I'm not fantastically good at this game, but we can now go through and we can now start playing our Uridium. So everything is up and running and we have our games all ready for us to work with. Now that we've got our Commodore 64 all set up and running, we're going to want to do a little bit of housekeeping. So we're going to want to put more software onto our USB drive so that we can use that then in our emulators. But if I have a look at the properties then of my USB drive at the moment, if I pull it up here, we can see that because I've used the disk image to create the bootable drive, it's come down as only a 300 megabyte hard drive. So our SD card, although it's a 16 gigabyte card, we're only using the first 300 megabytes of it. Now, if you have created your USB card using the file download option, then obviously you'll have built yours to the full size. But most of us, I guess, will have used the image and we're stuck with this 300 megabytes. So let's have a look and see if we can actually make that bigger. Now the problem we have is that there are some disk partitioning utilities built into Windows. So if I go into my Windows here and go to the command prompt and startup and administrator prompt, so inside here, okay, so I can use a program called diskpart, which will let me see what's going on. And inside that, if I then do a list volumes, that will show me all the volumes I have on my computer. So again, my USB card is plugged in here as drive K, and it's saying here it's an FAT partition of only 300 megabytes or 299. Now the problem I have is if I try to select volume 12 and then try to extend it, Windows will give me up an error saying that the FAT file system cannot be extended, and that's because our Windows can only extend NTFS partitions. So we're going to need to use a different bit of software to get around this. So there are a range of partition tools that you can use. If you're on Windows, like I am, I'm going to advise using this one called Partition Wizard, which you'll get from this download here, this website here. So I scroll down, on the home user side there is a free version which has really all the tools that we're going to need for what we're doing here. So we just need to go off then and install that. So once we boot up this partition wizard, you'll see all of your disks listed on the system. And the one we're interested in, of course, is this disk number 5 down here, drive K. And we can see there we have our 300 megabyte partition and then 14 gigabytes of unallocated space. So all I'm going to do is I'm just going to right click on that partition. I'm going to say I want to resize that. All I'm doing then is just going to drag this out and I'm then going to say OK to that. It should give me an idea here of what it's going to look like. So I'm going to use the whole USB stick for this drive K. It hasn't yet applied that, so I just need to apply that and that should then go through and resize my partition. So now that's done, we should now have our drive as it was before, but now using our full SD card. So if we now check the information for our USB drive, coming in here, you can see that it's now saying that we have a 14.4 gigabyte drive with our 14 gigabytes now free. So I should be able to come across here, take my entire Commodore 64 library, and then just simply drop that into my Commodore 64 disks on the USB drive. So really the last thing I want to sort of just show you with this emulator, we did at the start say that this does emulate a whole range of the Commodore 8-bit computers. So let's have a look at the VIC-20. So again, I have gone through the process of installing the ROM files for VIC-20, and I've also loaded a few cartridges into my system. So if I go back into my settings here, if I come up, what I can do is I can go to the machine menu, and in here I can switch the machine that I want to be emulating. So I'm going to go to a VIC-20. Now it does come up with a number of options here, and so sometimes you will have to go and play with which particular version of the VIC-20 you want to go with. But I know on my system that the HDMI Vice 720p does seem to work quite well. So we're going to reboot then back into a VIC-20. And there we go. And again, we're now sat at, in effect, a VIC-20. But again, we can do exactly the same things we did with the Commodore 64. We can go into our F12 to get to our main menu. We can come down here. I can pick up a cartridge. But actually, before we do that, we do need to set up, obviously, our joysticks for this one. And again, that's all done in exactly the same way. So let's come down here and we'll configure our gamepad 2. And I know that that is exactly the same as before, so I need to just set up that. Then come out of that, then connect it up to my gamepad, and then go down and save that settings. And then we're going to come up, and I'm now going to attach a generic cartridge, because I have them all as cartridge games. And let's go down here, and one that I like playing is something called Jupiter Lander. And let's do that. And there we have Jupiter Lander now on our VIC-20. So let's have a go at that. And you can see there that we have our Lunar Lander game. And we can play that on our VIC-20. So that's really the bare metal emulators for the Commodore series covered. A really good way of producing a standalone Commodore 64 or VIC-20 or whatever you want, especially if you are going to be building a replica machine where you're perhaps putting a Raspberry Pi inside an old case and connecting up the original hardware, but want the modern electronics inside that with the HDMI output and everything. So, hope you find that useful. If you've liked that video, please do click that like button and don't forget to subscribe to the channel. I look forward to seeing you again in another video very soon, and bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.